Show that this integral is equal to 2/3. The diagram shows part of the curve this. Mark claims that the total area between the curve, the x-axis, and the lines x equals 0 and x equals 2 is 2/3. Explain why he is wrong. Calculate the total area between the curve, the x-axis, and the lines x equals 0 and x equals 2. Okay, I paraphrase the question here. Let's do the first part then. So the integral between 0 and 2 of x squared plus 2x minus 3 dx then is equal to power rule, raise the power by 1, divide by that number, plus 2, x to the 1 this is, so raise the power by 1, divide by that number, minus constant integrates to constant times x. So we're integrating this now between the bounds in the range of 0 to 2. So that's equal to then, put the template in, top value, take bottom value, put 2 in, 2 cubed is 8, 8/3. 2 in here, this 2 will cancel, and we'll just get 2 squared is 4. And then put 2 in here, 3 2s are 6, so minus 6. And the 0, they'll all be 0, won't they? So this is equal to, this is minus 2, 2 and 2/3, minus 2 is 2/3. Okay, so I'll put that over here, 2/3. Part 2, Mark claims the total area between the curve, the x-axis, the lines x equals 0 and x equals 2, is 2/3. We've just worked out that integral, haven't we? And we've got this segment here. That's the area in question, isn't it? Okay. Mark claims that the total area between the curve, the x-axis, and x equals 0 and x equals 2 is 2/3. Explain why he is wrong. He's wrong because the curve crosses the x-axis, doesn't it? Because the curve crosses the x-axis, so it's not as simple as just working out the integral. So let's calculate the correct area then. Here, area is equal to then, well, it would be the integral, the area between, which is positive, this part here between 1 and 2 of y, 1 and 2 of x squared plus 2x minus 3. And then the other area that we have to add on is underneath, so it's a negative, so we have to put a minus in to make it a positive, don't we? And that was between 0 and 1. So that's equal to then, let's do the same again, x cubed over 3. 2x squared over 2 is just x squared as before, minus 3x. So we've done that integration. The first one needs to be evaluated between 2 and 1. The second one needs to be evaluated between 0 and 1, doesn't it? So what have we got here? Okay, so we've got this top value is here, and that was 2/3, wasn't it, when we put in 2? So we can write 2/3 straight away. Take away the bottom value, put 1 in, 1/3, minus 1 squared is 1. 3 times 1 is 3. So there's the bottom value. Minus, now top value will be the bottom value that we just got here, wasn't it? So what is that? That would be 1/3, minus 1, minus, why have I put minus 1 here? It's 1/3 plus 1 minus 3. Take away 1/3 plus 1 minus 3. Take away the 0 is the bottom value. Sorry about the mistake there, putting a minus. So what have we got then? We've got 2/3 minus this lot, and it's the same here, so it's minus 2 lots of 4/3 minus 9/3 minus 5/3. So it's 2/3 plus 10/3 is 12/3, which is 4 units squared. It's a measure of area.